Welcome. In this video, I'll take you along through the software setup of my home server. In my last video, I restored a used ThinkStation P500 workstation. In this video, we'll set up a Linux OS on it, we'll set up file sharing through Samba, Plex Media Server for media, we'll also set up a container environment with Docker and Portainer as the user interface to manage Docker through a web UI, we'll also set up Firewall, and a DNS server with pihole. The first step is to install Arch Linux on the system. Now, for the video, I will do the installation of Arch Linux on a virtual machine, not on the actual workstation. I already installed Arch on the ThinkStation before making this recording, and I will do the same installation on the virtual machine to demonstrate the install, but be able to record it with high quality. After we create a bootable Arch Linux install medium, which you can do from the site, and boot that with the USB drive, you can start the installer and we'll wait for it to boot. You'll basically be logged in as root, and you can run Arch install to run the automated install utility. Alright, this guides us through multiple steps which we can configure our system through. First language, I'll leave that to English. Mirrors, I would like to choose a mirror region. We can press / to search, and I'll do Germany in this case and select that as the mirror region. This is of course the mirror for Pacman from where our packages will be installed. So it's important to choose a country close to you. Okay, I'll leave everything to English, US and UTF-8. This configuration. So on the actual system, I use the best effort default partition layout on the SSD drive, because that's what I want to do. Here, I'll do the same thing. I have a virtual drive created from my VMware virtual machine. I choose that. And now the file system is now by default BTRFS. I will use ext4 for performance reasons. You can read about the differences between the different file systems. BTRFS has some features which ext4 doesn't have, but for my server I will go for ext4 for now because of stability primarily and performance. Alright. Disk encryption, I do not need disk encryption on this stage for my server. You can turn it on if you want. I will use systemd boot for the bootloader, as is the default because it's lightweight and unobtrusive. Leave swap space to true, of course. Now, for hostname, I will actually modify this to home server in order to be able to utilize this to access some of the services more easily with the hostname of the machine. Now, root password, I usually leave this blank as it says here to disable root because I don't need the root user at all. I found that it's completely useless and I never pretty much use it for my use cases, especially for the server. On a workstation, some very limited cases. User accounts, I will add one right now. Let me just type the password. And as I don't have a root user, I will of course make my user account a super user. And type confirm and exit. Alright. So I've set up our user account so far, bootloader, disk config, everything. Next is profile. This is the package installation profile. You can choose anything here. As I'm doing a server, I would want some packages from the server profile. If you open that, you see I want Cockpit. That's a web user interface through which you can manage your server. Because I'm not going to install a graphical user interface to the server. It's not gonna be hooked up to display or have a keyboard and mouse. I would want to access it remotely. You can, of course, I'll also install SSHD in order to SSH into it if necessary. But Cockpit is very nice because it's a web interface with graphics. For most things, it will do the job great. I will also install Docker because I will use Docker containers on my server, but you might not need to. I would recommend Cockpit though, and SSHD for sure to be able to SSH into your system. At minimum, you should have some way to SSH into a system. And I don't need any of the other things. We have Nginx, Postgres, databases, not necessary at this stage. All right. Press enter to save my choice and go back. And we have the profile selected. No audio necessary. Kernels. Now, you could choose the LTS kernel for a server. I would like to go with the default kernel. I could see the case why you would want long-term support kernel on a server, but not necessary in my opinion. The default kernel is good enough for most use cases. Now, for additional packages, I'll not install these right now. I will install some additional packages after the Arch installation is complete. All right, network configuration. I will use Network Manager, of course. In fact, Cockpit also uses Network Manager to give you network information and network management UI. Time zone, I'll select mine. And automatic time sync, I'll leave that to true. I won't enable any other optional repositories, and basically I can start the installation. That's pretty much everything we need. You get a preview of your config. All you have to do to just confirm it and start the install is press enter. And Arch install will go through the steps of formatting the partitions and installing all the packages and bootloaders and everything necessary for the system. I'll speed through that process and we'll continue the video after the installation is complete. So the install is now complete and the Arch installer is asking us if we'd like to tree root into the newly created installation. I would actually not want that. We will now use Cockpit to log into the actual ThinkStation on which I perform the exact same Arch installation, and we'll continue from there. Okay, so basically at this stage, after I installed Arch on the home server, I moved the system to the server room, plugged it in, started it, and plugged it through a WAN connection to my router. And you can see it appears right here. This is my router control panel. I'm using the TP-Link Omada system. And from here, what I did was just assign a permanent IP address to it so that it doesn't change its local IP through DHCP. This way I can access it through this IP address and I can forward ports, external ports from my router to this local address. What this helps me to do now is actually log in through the Cockpit web UI through this address. You can see if I paste that and do port 9090 is the default port on which Cockpit works. I now get access to the web UI of Cockpit into my new Arch server. I will use my user account, which I set up in the Arch install process, and I can log into the server. All right. So when we log in, this is what the initial Cockpit view is. You have a sidebar with multiple panels and multiple capabilities to see the overview of the system, log, storage, networking, account services. We will enable more items here. This is just the bare minimum which Cockpit supports. We also have access to a terminal directly into the system, as you can see. And in the overview tab, we see health, some basic usage metrics and history, and system information. We can also, there's a configuration panel where we can do some basic things. We see the host name and time zone and the system time. Now, here's what's important. First, we want to go to the terminal and update our system, although it should be up to date, but just to be sure. This is an Arch system, so we're using Pacman. Update our system if I can type in the password correctly. Okay, so the system is up to date. Now, the next steps are to install some necessary utilities. I will install Git. We'll need that for sure in order to install some packages from our and pull repositories of that. I also install Nano, the text editor. For convenience, we will need Samba, and I'll open the Arch Linux wiki. It has a very good article on Samba and the exact dependencies you need. All right, so you need the Samba package, of course, that's clear. We also need the Avahi package, that's for discovery of our network drive. So I don't know if I mentioned, Samba is the actual file sharing server which we'll use for our NAS. which provides files NAS drive sharing through the SMB protocol. Avahi is used for discovery on some Linux systems, and we will also need, now that's a good reminder, we'll need a firewall. Let me open the Arch Linux article on Cockpit though, and I'll show you why. Now, as you can see here in the Arch article about Cockpit, which is, if you remember, this web UI, we have, the Cockpit package, which we've already installed, and then some additional features which can be installed through some other packages. We'll go through these, but also Cockpit works with some specific packages for a firewall, to manage storage, and for networking. Now, we already installed Network Manager because of that through the Arch install, and I will install Firewall D as my firewall to actually use the Cockpit UI to manage my firewall needs, false ports, etc. I'll install udisks 2 for storage capabilities in Cockpit, and we also need a Cockpit storage D for the same reason. I don't need Cockpit Podman as I'll be using Docker containers. Cockpit PCP is also needed for metrics and other important, I wouldn't say important, but useful information about your system, lifetime metrics, etc. So let's run that, install all of these. All right. So we've taken care of our firewall and we have Samba. The next step would be to actually reboot the system. And as you can see, I can do that from Cockpit. In the Overview tab, go to Reboot and just select No Delay to reboot immediately. Now it's disconnected. I always like to refresh because I also added plugins for Cockpit which might need to hold here. Okay, the system rebooted and now I can walk back in with my user details. So here's what we've got installed here. Under networking, we now have a firewall, which is currently disabled, but we will enable it later. Under storage, we have, first of all, because of storage D and disks 2, this overview of our file system, our disks. As you can see, we have def SDA, which is our SSD, and the file system on it, def SDA2. And then we have our SDB disk, which is our hard drive, 4 terabyte hard drive, which we use for storage and share it with Samba. We also have our optical drive, but this entire storage section will be used to manage drives. I can also open a drive and create the partition table for it and format it. And in fact, this will be the next step we'll do right now. This is our SDB drive, the 4 terabyte hard drive. I'll create a new partition table on it. Alright, compatible with modern system, basically GPT, yeah, it's 4 terabyte drive, there's no other option. We don't need to overwrite existing data with 0, this is a brand new disk. And we initialize it. And now we have free space here, on which I'll create a partition. It will be with SDB1. I'll mount it to mount SDB, and ext4 will be the size, 4 terabytes, no encryption. At boot, I want to mount without waiting, ignore failure, after network becomes available. I want to mount it before all services start. This is very important because I don't want my Samba service to ever start before my drive is actually mounted. And I don't want read-only, I want the default options, which are read and write on the drive. And I'll create and mount it. This might take some time, I'll fast forward until the process is finished. Alright, the new partition has been created and it's mounted at mount SDB1 as I instructed it. As you can see, the mount point is set. Now, just to be sure, I'll actually go to the terminal and go to etc and check the fstab file where the actual, where the, this is where the mount points are defined, and I wanted to check that it created an appropriate default, and here it is. This is the ID, a unique ID of the partition we want to mount, and mount SDB1 with default. So it worked great. I am happy with that. We now have our partition and our free space. Okay, next up, let's check Samba. I did install it. It's not running, but the Samba service shouldn't be running. I would like SMB to be running. And it's not. It's not even the same enabled right now. So I will. As you can see, I should mention that Cockpit has a very nice services view. This is essentially your systemd services, and you can search for them, enable and disable them through this UI. It's quite awesome. It also supports walks, you'll see in a minute. So I'll enable the service first, and it fails to start. Oh yeah, so I forgot about that. If we go to the Samba article, we'll see that before starting the Samba service, we need to actually create the SMB conf file, the actual Samba configuration, because it doesn't have any default config by installing the package. But before we do that, I want to install a plugin to browse files here in the Cockpit UI. This plugin is not available in the Arch Linux repository, so I'll go to the Arch user repository, and search for Cockpit. And here we see multiple plugins. Cockpit Navigator is what I want. To install it, I'll actually first install Yay in order to be able to update packages from our. To install it, copy the git URL. I'll go to my home folder and clone it. Okay, and just use make package to install it. Okay, I also use pacman to install the base devel packages. Those are necessary for many our packages which we'll install with Yay. So now that we have Yay installed, I can look for Cockpit Navigator again, and I can just install it with Yay this time. Yay is very similar to pacman in terms of syntaxes, and we proceed with the installation. Now we have our navigator installed. So I will first go back and remove the Yay folder, the Yay repo folder from my home, because we already installed that. And I should be able to just refresh Cockpit. And there we go, the navigator appeared. Here's what the navigator is. It's basically very similar to Nautilus or other file managers. It's very useful though, because you can edit some settings files in the built-in text editor. We need to create a new config file for Samba in the etc Samba folder. There it is. So here I'll create a new file. I think it should be smb.conf. Yes, exactly. All right, and open that file. Now, if we read the wiki article, there's actually a default file in the Samba Git repository which you can copy to start from it. This is some basic explanation, guides, and these are the global settings. I have a workgroup here. Mine is workgroup. Server string. I'll leave that to Samba server because it's alright. Server role, standalone. This is important. Here you can choose different types of Samba servers. In most cases, if you want basic file system sharing, you would want a standalone server. Samba has other capabilities as well. For example, being an Active Directory domain controller and other things. Well, I want a standalone server to share a drive. This is one of the line items we will touch on. Hosts allow. I wouldn't want to allow everything. So I would like to allow only certain subnets. Let me just see. Yeah. So this is my local subnet and I want everything under it to be allowed. I don't want a guest account. Yeah, this is the work file. The default location is fine. It does have a maximum file size, which is nice. It should have that in order not to bloat your system with walks. So, the important options, most of these are just fine, the global settings. Here we have shared definitions. and we will configure some shares here. Let me just first comment the home share. I don't need that. What I need, these are, as you can see, multiple templates for printers, which is actually enabled. Let's comment that. A temporary file space, public share. I want very basic config, which is very similar to the last one. Yeah, the following two entries, how to share a directory. In this setup, the directory is writable by both users. Yeah, this is for multiple users. So this is the share I'll use. I'll call it NAS. This is the share name, if you didn't figure that out. I don't need a comment, it's useless. Okay, so what we're gonna share is the drive, the 4 terabyte drive, which is mounted at mount SDB1. If I'm correct, I just saved the file to check because I don't trust my memory. Let me see. Go back. Mount SDB1. Yeah, this is what we basically want to share. Let's go back to etc Samba. Yeah. Okay. Valid users. Here you need to enter users which are allowed to log in to your Samba drive. For now, I'll just add my user. It will not be public. It will be writable as well. Printable is pointless in this scenario. Create mask, the default is fine for me and my scenario. So this should actually be pretty fine. What I'll do is I'll just clean up a little bit this these other scenarios because I really don't need them, and check if I missed something. Think everything is correct. Yeah. Okay, so I'll leave just that. I will not delete any of the above because they are the global settings with comments, and I think they are very useful. All of these comments explain the basic meaning of the setting beneath them. I think that's great. All right, so I have my shares defined and I'll just save the file. Let's now start the Samba service. And we are running. That's actually great. Okay. The easiest way to test this is to just attempt to open it here on this computer, which is on the local network. Yeah, that's how it should work. All right, that's a very good start. We get to the login screen. Now, I won't be able to log in with my user because I haven't set a password, a Samba password for this user. But so far, everything's working great. And here in the walks, I should have gotten a walk. Yeah, as you can see, it detected the connection from my IP and attempted to open a new walk file for my user, but it didn't exist. So let's add the Samba user. You can use the smb pass wd command -a. I mean, we can print the help actually. smb pass wd -a is to add a user, and I'll add a new user here. So sorry, I need to run this as a sudo, of course, in order to add that user. And I can type the new SMB password here. I'll just quickly generate a secure password. So I generated a password for my password manager and I'll just type it very quickly. Okay, I typed a new password for the Samba user and we now have it. So the next step will be to just attempt to log in now again. And I'll use my new user. Then we have our drive. I open it, we have the lost and found folder, which is great. Okay, so we have our first service. Our NAS is up and running. The drive SDB1 is shared. That's great. The next service we have to add is Plex Media Server, which is going to be a little bit more complicated because I would want to add it as container, and I would like to have the ability to work with containers in general. Actually, first of all, I can see that we don't have the ability to do software updates in Cockpit right now. So I'll first tackle that. To do so, I'll use pacman ss to search for packages containing Cockpit. And we can see we already have Cockpit installed. Cockpit machines is for virtual machines. I don't need that. I need that, the package kit. So I'll install that. And I have all of the others. So if it installed successfully, if I refresh now, I have applications, first of all, and software updates. I wanted that update and that tab in order to be able to run the pacman syu command from the UI. It's a little bit more convenient. I don't know if I'll use it, but it's a nice capability to have. All right, so now let's tackle containers. I will need Docker. I'll just install it with pacman. Total installed size 100 megabytes. Okay. If I go to services now, I can look for Docker and it's enabled and running. That's great. So next up, we need Portainer. Unfortunately, Cockpit does not support Docker UI management, but there's another excellent utility for that called Portainer, which I'll use. And we can find it right here. It's basically a web UI to manage Docker. It has many other capabilities. I'll use it as its most basic form. Now, the interesting thing is I will not install Portainer on the machine. It will actually be the first Docker container which I'll have on my server. So to do that, I'll go to Docker Hub. This is the repository of containers, of Docker containers. And I'll look for Portainer to find the official Portainer Docker container image. And the first one, as you can see, is deprecated. You should use the Portainer CE, a lightweight service delivery platform. Great. And here we have to, of course, pull the image, but that's not the first thing. There's a getting started guide, which we can access through deploy Portainer. Okay, we are interested in Docker standalone and Docker on Linux. And this is the Portainer documentation. Now, as you can see, it's very straightforward. We need to create a new volume so that Portainer can store its data somewhere. Pretty normal for a container, which we can create with just a single command. I don't care how the volume is called. Portainer data is pretty good in my opinion. I'll need to run this as a super user. And we have our volume already. And next, we just deploy Portainer. This is the standalone Docker command. Now, this will run the image as in the background. It exposes port 8000 and port 9443. It names it Portainer and sets restart to always, which is exactly what we want. And the rest of it just shows the Docker Linux socket where it can find the Docker service essentially, and then sets the volume, Portainer data, and lastly is the image name, Portainer C latest. Latest is great because I always have the latest version of Portainer when I update my images. And we run that. As you can see, it didn't find the image locally, so it downloaded. And we'll wait for it to download Portainer and deploy our container. Okay, so now if I run sudo docker ps, I have my Portainer container that's running. As you can see, the status is up since 7 seconds. And the exposed UI port, the exposed ports are 8000 and 9443. I believe 9443 was the port at which I can access the actual user interface. So let's try it. Whoops, wrong IP address. Client sent an HTTP request to an HTTPS server. Okay, yeah. And there we are. So this is the first time we are opening the web UI. We're still in the installation, essentially. And I need to create the initial administrator user, which I'll do right now. I will again generate a password and unpause the video after that. Okay, I generated a new password that should be strong enough. Our collection of anonymous statistics? I don't think so. You can also have the option to restore it from backup. This is very useful because if you think about it, we are talking about a container management system here. And when we deploy our containers here, our servers, everything, we can just back up through Portainer and save a backup file. And if something goes wrong or you want to create a new server instance, you can just restore the backup here. Okay, so create the user. And here we have the option to add multiple environments. I'll just want the Waco environment, which is the Docker instance on my server. And here we go. We can open it and see that we have one container running. That's the Portainer container actually. And that is awesome. Now, let's deploy our Plex server next. We have to start at the Docker Hub again. And the Plex Media Server is actually PMS. This is the official Plex Media Server Docker repo. Plex Inc. PMS Docker. And here we have the information which we need to set up the container. There we go. Usage on host networking, and that's how it works. Great. So, to do so, we add a new container, basically. I will name it Plex Media Server, the Docker Hub registry. Copy the name of the image. All right. And let me see. Yes, exactly. You can verify that it's correct by searching, and we find it, so the name is correct. Always pull the image in order to update it. We actually don't need to expose network ports because I'll set that to the host network. A little bit more about that. And now we need to set some settings. Volumes is the first thing. Here, if we see what we need basically 3 folders. The database, or the config file folder where Plex will store configs, a transcode folder which Plex will use, and the folder with data, where the actual media will be. I use Plex for movies, pictures, basically all kinds of media files. And all of these I want to be in the shared network drive. We need to set these 3 volumes. To do that, I'll go to my Cockpit and I'll go to my navigator. I want my config folders to be in my home folder first. I'll create a new directory here called Plex. And in it, I'll create the config and the transcode folders, which it needs. Config first and transcode second. All right. And the media folder, I don't want to be on this drive where the OS is, but I want these 2 folders to be on the SSD so that Plex can access them quickly. The actual media files will be in the shared drive, which is in mount SDB1. There we go. And here I'll create a new directory called media. There we go. And that will be the dirt volume. So now I have to map these here in volumes. Volume mapping. As you can see, we have path in container and the path on the system. And we can either create a volume like we did with Portainer data or just bind. I prefer to bind paths when working with containers. So there we go. Let's start with the config. The path in the container will be config. The path here will be home Plex config. There we go. This path. Okay, let's add the second volume now. It will be transcode and bind the transcode folder. I prefer to copy and paste to avoid annoying errors which take ages to debug. And lastly, the data basically will be my media folder, which is mount SDB1 media. There we go. And these are the volume mappings that we need. Network will not be bridge, it will be host. This means that the Plex Media Server container will use the host network. All ports which are exposed on it will be exposed on this container, which is exactly what I want. In fact, the virtual NAS of Docker is the most performance-hitting bottleneck of Docker containers, and I prefer not to use it whenever possible. And environment variables, we actually need some, I think. Yes, we need a time zone, TZ environment variable. I'll just set it to my time zone. Do we need anything else? I don't think so. We have our 3 volumes. I don't have a token for Plex, and that should be it. Okay. On the restart policy, we'll set it to always. We want it to be running all the time. Even if it fails, it should restart itself. Yeah, so this is why I didn't need to set ports as exposed, because I set the network to host. Essentially, all ports are exposed this way. And I will deploy the container. This might take a few seconds. Okay, so it failed because, of course, I have an invalid container name. Of course. I'll actually simplify it to just Plex. I don't know why I said such a complicated name. And now we have our container starting. We have to wait for it to be running first, and then we'll see if everything is running correctly. Okay, so let's test it. If we scroll up here, you will see the port of the web UI. There we go. Yeah, 32400 is the port where we can access the web UI. So I will type the server IP and 32400, and that's actually great. The server is running. -web is the web UI of Plex. There we go. So our Plex Media Server is actually running as expected, and it was extremely simple to set up. Just deploy the container and start it. And so far we are running as expected. We do have an unhealthy message. Let's check why that is. All right, so after a few minutes I could find the error and got this to a status of healthy. Here's what the problem was. In the etc hosts file, by default, file is empty on Arch, and the container was expecting a local host pointing to the local IP address, which I added and restarted the container. And now the service is running as expected and it's healthy. Okay, the last step is to take care of the firewall. If I go to the networking tab in Cockpit, I can enable the firewall and edit the zones. So first of all, we have SSH. We have a public zone, which allows the entire network, everything basically is public. So I will add a new zone, which will be my zone for my home, and I will include only a range, my local IP address subnet. That's basically what it will include. And it will work on this interface. Yeah, I want the zone. So it enables Samba, DHCP, MSDNS, and SSH, and also Cockpit. Great. And here I need to add Plex. As you can see in the firewall settings, although Plex isn't a service on this Arch Linux install, it basically is running in a container. It doesn't recognize it, but it has the information what ports Plex uses, and you can just add them like this. It's very nice, convenient. Also, yeah, basically our Samba and our Plex are running correctly, so everything should be fine. Now the last step, I'll show you how to install pihole. Pihole is network-wide ad blocking, and basically it's a DNS server. And I do use it at home for both ad blocking and as a DNS server because it caches DNS. It's pretty nice. And we will also deploy it with the official Docker images. There we go. I'll go to Docker Hub again and search for pihole. Here it is, the official pihole Docker image. And here are the settings. So let's deploy it the same way by creating a new container. I call it pihole. And let's check the settings which we need to set. Here we have a Docker Compose example from which I can see the volumes and ports it needs. So it needs a couple of two volumes actually, etc pihole and etc dns mask.b. So let's set this up. So let's set up the volumes. I will again go to my navigator and create these in my home folder. In my home folder, I'll create a new directory called pihole. And here I need two folders, etc pihole. I will actually call it etc and DNS mask. All right. So let's set the volumes. We have etc pihole, the first one, which I'll set this path right here. I've prepared for it. Actually, this is the path in the container. This is the path on the host. And also I have etc DNS mask directory, and I'll bind it to this folder right here, which I created specially for that reason. And network, excuse me, network is going to be host again, and no additional settings are needed. For environment variables, let's see what we need. Again, time zone, pretty standard. And web password, there we go. We have to set the password as an environment variable here. So I'll generate a strong password again and unpause the video after that. All right, I've generated my password, and going forward, restart policy will again be always, and so far we should be done with our pihole container. I'll just deploy it now and wait for it to start. Okay, my pihole just started and it has a status of healthy. I'll check the logs anyway. Yeah, everything seems to be working without any errors whatsoever. Now the bad things about pihole is that it by default runs the web UI at port 80. So I should be able to access it right here. Let's see. Oh, I did enable the firewall. So now I will need to add a new entry for pihole. Do we have it? No. So custom ports. I need, again, 53 and 80 TCP and 53 and 67 UDP ports. There we go. Okay, ID will be pihole, sorry, and we add that. Great. Now I have my entry, and now I should be able to access it. There we go. And let me just copy my secure pass. All right, I copied my secure password, and let's log in now. There we go. So we have our pihole. To use it, you just have to set your DNS to the pihole address, which will be my home server in this case. And that's all. It will block all ads. The good thing is it has an ad list right here of what it will block. It's fully transparent so you can see it. All of the different analytics and advertisements. Pretty great. With this, I'll wrap today's video. We set up a home server with Samba, Plex, Portainer, Cockpit, and a pihole. We also are able to deploy multiple containers, and I'll surely add more services to my server as I go. These are the bare minimum services that I need for media and file storage. Don't forget to subscribe to get notified when the next video is released. Take care.